Alright, we're getting ready to start the second largest topic in Calculus 1, and that is antiderivatives and integrals. And so what we've been doing is taking the derivative, and what we're going to be doing is doing the reverse of that. Given the derivative, we're going to find the original function, and known as the antiderivative. Integration and antiderivatives use the same rules. So, what is the theorem for an antiderivative? It says that if f prime of x is equal to f of x, then f of x plus c is the general antiderivative of f of x, where c is an arbitrary constant. Now, I'm going to explain that a little bit more as we work through some of the problems. So you'll hear me refer back to this idea right here many times today. The general antiderivative of an x to the n is you take the x and you raise it by 1 and you put it over that same power. So say this was x to the third. Well, what this is saying to do is to say it's x to the third plus 1 over 3 plus 1. So in other words, it's x to the fourth over 4. Now, we'll go into that in more detail as we start to work through these antiderivatives. So what I'm going to ask you to do, first of all, is find the antiderivative of a constant. The antiderivative of this constant number would be f of x is equal to 4x plus c. Think about it this way. If you were going to go backwards, and I ask you to take the derivative of this, you would tell me that the derivative of big F would be big F prime, and then you would bring this out front and you'd tell me it was 4. Take the derivative of the constant is 0. So you can check every single one of your antiderivatives by taking the derivative of it. Let's do another one then. So we're going to find the antiderivative of x. Well, you raise it by 1. The exponent there is 1. You raise it by 1, and you put it over that same exponent. While that looks funny, really all it says is 1/2 x squared plus c. Here's my check. I'm going to check to make sure I did it right. If I take the derivative of the big F, okay, I'd bring the 2 out front. 2 times 1/2 is 1. X, lower it by 1, 1. Take the derivative of the c, which is just 0. So notice how I get back to where I started. So this is checked out. It does work. The antiderivative is correct. The next one, so that was my solution. The next one is the same thing. The rule is raise it by 1 and put it over that same power. Add the plus c. I'm going to check this. When I check it, here, I'll rewrite this first. So it's 1/4 x to the fourth plus c. This is my solution. When I take the derivative of this, bring that 4 out front, I get x, lower it by 1/3, take the derivative of any constant, I get 0. So it does check out. Let me go back and address this whole constant thing. The reason why we have to name it c is because there's so many different solutions. If I was to take the derivative of this function right here, f of x equals 4x plus 5, and I took this derivative, the derivative would be 4. If I was to take the derivative of this function, 4x plus 6, the derivative of it is 4. So that's why when we take the antiderivative, we've got to add this plus c, because c is an arbitrary constant. We don't know what's being added on. We don't know what the constant is on our original functions unless we're given more information about it. So we always are going to have to remember that plus c. Do not forget the plus c, otherwise it will be incorrect.